Everybody. Um, I realize that I'm going through this list of functions a lot quicker, but we've gone so far through the list. I think we should all be picking up on the patterns here, and some of these are just really simple. Starts with is another example. There's a starts with. I thought it was on the string prototype, but maybe it works with strings and booleans. I mean, strings and lists. Anyway, we could go check. This probably was covered with ends with as well in the first series. But I mean, let's just look at the example here. We give it a list of things to check if it starts with that one of those things, and a list, and it gives you back true or false, or it gives you, or you use strings. So in this first example, we give it a string ABC, and we ask if it starts with A, and it does, but this one doesn't. Um, okay, so there is something a little unique about that. If you pass it an array, you do need to pass it an array of the thing you're trying to check. I would assume, if I just guessed how this worked, that you would not need to pass it an array. You could just pass it the letter or the string A. But this is how it works. Yeah, I don't think there's much more to say about that. It ends with is the same thing. Um, so I'm not even going to do an example. I think the example here is just as clear as anything else. And again, another easy one, subtract. We've looked at add. Subtract is the opposite of add. But the one thing you have to worry about is, I say that, if you do subtract 3 and 2, we're going to get 1, right? And that's easy. But if you partially apply it and you say, I want to subtract, uh, let's say for decrement, and you pass it a 1, and then we decrement 3, you might think we're going to get 2 back, but we get -2 because this is the second argument because we partially applied it with 1. So for me, when you have something like this, I think of it like in some languages you could do this, right? And that's the same thing. So just physically pick this up in your mind and move it to here and pretend it's in between the two arguments, like in fixed notation. And I think it makes more sense. So in this case, we could flip the arguments, and then run that. And then we should get a negative number, or not a number, flip. Oh, sorry, I do this all the time. We're flipping the arguments of the function, and then we pass the second argument, really, because we're flipping it, and we get 2. So 3 minus 1 is 2. Uh, or we should be able to use Ramda's placeholder and do r dot subtract r dot underscore underscore, and then 1, and we still get 2. So either way, um, and can we do it like that? Does that make sense? We did that. We could do 2 have to think. Yeah, we get -1. So we're doing 3 minus 2 instead of 2 minus 3. Yeah, anyway, that's subtract. I think we looked at that. That's just a quick overview. And then we look at sum, which takes a list of numbers and adds them together, right? So I'm not even going to do an example of this one either, but yeah, I am. So we pass it a list and it adds it together. So if we didn't have this, likely the best solution would be to use r.reduce, pass it the add function, and then we need to give it the starting value, which is 0, and then the list. We'll do that list, which is 1, 2, 3, 4, 5. Add those together, and you get 15. We get 15. Or we could just sum the list, and we also get 15. So much cleaner. And likely, there's product, which is very similar. Does it even say? It doesn't say C product, but um, product it multiplies the numbers in a list together. We get 120. And we could do that with reduce by doing r.multiply. And then the starting value is what is the identity of multiplication such that the number that you pass in, or if we pass in a number a, what do we multiply by a that gives us back a? And it's 1. For addition, it's 0. But for multiplication, it's 1. And then we give it the d.list, and we multiply this together, we still get 120. Yeah, so that's sum and product, which is related. And then we get something a little bit more interesting. We get swap, right? And this is a list method, list function. So r.swap. So this is, so it takes a number and another number and a list of anything, list of A, and it returns a new list of A's. What we do is we swap an item at index A, which is probably this, with another item at index B, which is probably this, in an object or a list of elements. So that's cool. You can do this in objects as well. A new result will be created containing new elements order. What? A new result will be created containing the new elements order. That's a strange thing to say. Let's take their example. Okay, so what we're going to do, we swap an item at index A with another item at index B. So here's index A, 0, which is going to be A. And index 2, 0, 1, 2 is C. We're going to swap this. We're going to put C here and A here. So we'll get C, B, A, D, E, F. There you go. Very simple, very useful. Because if you do that, otherwise, you're going to use splice probably, which is mutable. There's the new toSliced, which is immutable. There's a method called with, which is very similar um, to spliced, but there's nothing simpler than this. You just tell it like, here's the one, here's the first one I want to move, and the second one I want to move. Now swap them. Um, but what's cool is you can do that with an object. All right, so let's say we have an A and a B, and we want to swap them. So then we have our object. I'm looking over here. So A1, B2, that's our object. And when we swap them, we get A2, B1. So it swaps the values, but not the keys. And I think that's what it means, the new elements order. So like the order of the object is A, B, and we're swapping A and B, but we still get back the same order, A and B, just with the values swapped. So if it's an array, it's going to swap the items in the array. If it's an object, it's going to swap the values for each key value pair. Um, and here you can do it with strings too. That's cool. 0, 2, and foo. So 0. We want to swap the item at 0 with the item at the second index. So the 0th index and the second index. And we give it the word foo. And we get oof, because we're taking the F and moving it to the 2 and the letter O at 2 and moving it to the 0. Let's do hello longer. And we get Lalo. Yeah, very useful and very simple. And so we have two more before we get to the T's. Let's knock those out. So symmetric difference. This is a relational one. The type signature says that we take an array of anything and another array of anything, and we return an array of anything. So it finds the set, and a set is, if we had x's with 1 and 1, and 2, 3 and 2, 3, 4, and 1, the set would be 1, 2, 3, 4. It's an array with no duplicates. That's all a set is. And of course, we have in JavaScript now, probably after this was released, we can do a new set and pass in 1, 1, 2, 1, 4. And if we log that, we get a set with a length of 3 that contains 1, 2, and 4. And notice these are curlies instead of square braces, because it's a set, not a list. That's what they mean by set. So it finds the set of all elements contained in the first or second list, but not both, right? So this is like intersection and all those other ones. Difference with. I think we've looked at these in probably great detail when Chris looked at difference and difference with. Um, so all the elements contained in the first or second list, but not both. So I would say this is like mutually exclusive lists. So there's one list. Let's make another list of Y's. And let's put in 31 and 11. And then let's log r dot symmetric difference of X's and Y's, right? Because we're just passing in two lists. Yeah. And so this is giving, so first it's going to check number one, and it's going to look in this list and if there anything in, is not, or sorry, is one anywhere in this list? And yes, it is. So we don't do anything with it. Same with this one. Then we get to two, we look in the other list, two's in there, so we skip it. Look at three, three is in here, skip it. We've already done 2 and 3. 4 is in the list, so we skip it, and so is 1. So none of these are exclusive. None of these are only in X's. They're all somewhere in Y's. Then we do the same thing with Y's. We look at 31. It's not in the first list, so we keep it. Same with 11, but all these other ones are in this list. So if I put a 42 in this one, then we get 42, 31, and 11. So notice that it's going to start with the stuff that's in the first list, and that's going to be, those items are going to be at the beginning of our returned list, and then it's going to go here. So it is preserving the order. Um, these items first in the list, then these items first in the list. So um, pretty useful. This is something I think people do quite a bit. There are some set instance methods in JavaScript, but I think they're all pretty much covered here. And I think they were covered here before, like I said, set was even introduced in like 2020, 2021. Yeah. And then so the last one in the S's is symmetric difference with. And the with, I think, is going to refer to with a predicate function. So the end of the type signature matches this type signature, except it's constrained where each of these things need to be of type A. And this is just saying these can be anything. And we're still getting this symmetric difference. So it still finds the set of all elements contained in the first or second list, but not both. Duplication is determined according to the value returned by applying the supplied predicate to the two list elements. So it finds the set of all elements contained in the first or second, but not both. And I guess the predicate function determines if the elements are the same or not. That's interesting. So let's use this. Work our way through that. So here's a predicate function. We're going to determine if two values are equal to, or sorry, if the value that we passed equal A, if that value of the prop A is equal to the thing you pass in, then it's equal. And then we've got two lists. List of objects. All of these are A's. Everything's A's, and every value is a number. And we want the symmetric difference between the two lists, list one and list two, if it equals A. And I see what they're doing here. Um, we're not just using flat lists, we're using lists of objects. And these objects could have a B property, a C property, those could be numbers. So, how do we determine if they're equal? Like maybe we don't care if they're all equal ABCs, ABC 1, 2, 3, and ABC 1, 2, 3. Like we don't care, or even ABC 1. Let me just do it. A, B is 2, C is 3. And then in this one, we could say A is 1, B is 32, and C is 42. We just care if they're equal by the A. We don't care about the other properties. But if this is a flat list, then we just check the thing. Like it doesn't have a key. So let me go back to their example and run it and log it. And so what we want is the symmetric difference. So we want the list that's either in A or B, or sorry, either in list one or list two, but not in both, based on the value of A. So A1 is not in here, and A2 is not in here. The 3 is, and 4 is. And likewise, 5 is not in the first list, and 6 is not in the first list. So that's why we get A1, A2, A5, A6. Again, very useful. And I mean, you'd have to use this metric difference with metric difference wouldn't work. I don't think, unless you passed it. If we went back to symmetric difference, we don't take a function as an L1, L2. Now it's checking the whole object. Yeah, and we get the same thing, but we could say equal prop is greater than 2. Let's go back to that, and we'll just use the same function name. It's not quite as correct now, but yeah, that doesn't work. I think it's because of my predicate function. I need to do it like that. No, that doesn't work either. The value of prop A is greater than 2. That's when they're equal. Yeah, and I read this last night. A lot of these functions end with the word by, and they're trying to be consistent with that naming. And when they say by, they mean by the value of a property, or a value. And this is like an expression. Yeah, so that's not working. If I wanted to do that, I could do art up pipe, start with that one, and then say, I don't want to flip it. Oh, I'll flip it. R dot flip, R dot greater than 2. Yeah, and that would work. How does it? So now we're just getting one list. We're just getting both lists. No, we're not. 1 and 2, 3 and 4. Yeah, we're getting both duplicates. So that doesn't make sense. So ignore that. Um, if you're going to do this, you just want to just tell it the value that it's equal by. Yeah, just looking at the A's. If we did B, would that give us an error or just give us an empty array? Gives us an empty array. Yeah, that's symmetric difference. Now we're done with the S's. Let's go take a quick look, see what we're in for. We get two T's. That's the end there. Yeah, so we've got all these. We're getting really close to the end, because we've already looked at a lot of these too, or some of them at least. But anyway, we'll pick up in the next video looking at the T function. Doesn't get any simpler than the T function. So thank you for spending your time with me. Tell a friend, and I'll see you in the next video.